Have you ever looked at something like a Roman aqueduct or an Incan wall and just thought, how? I mean, really, how on earth did they build these incredible things that have lasted for centuries, way before we had physics or calculators or any of the modern science we rely on? Well, let's get into it, because the answer reveals a totally different kind of genius.
It really does seem impossible when you stop and think about it. Today, we lean on these super complex equations and computer simulations to build pretty much everything. They had none of that. So, what was their secret?
And that's the real puzzle, isn't it? They didn't have written theories about structural stress or how much weight a beam could hold, no textbooks, no professors, and yet their creations have outlasted countless modern buildings. It wasn't magic, and nope, it wasn't aliens. It was a method.
The secret, it turns out, lies in a completely different way of solving problems. It was a hands-on, practical kind of science that was rooted not in abstract theory, but in the real world. This is the absolute key. Ancient engineering wasn't about predicting what would work based on a formula. It was all about discovering what worked through relentless real-world experience. You know, knowledge wasn't learned in a classroom. It was passed down directly from a master to an apprentice, right there on the job site.
And this wasn't just random guesswork, not at all. It was actually a really rigorous cycle. First, you observe nature and what worked before. Then you build something. And then you let nature, the wind, the rain, the earth itself, test it for you. If a wall crumbled in an earthquake, they didn't see that as a failure. They saw it as data. They just adapt the design and try again and again until it finally stood strong.
Okay, so that's the theory. But how did this method actually work when faced with some really big real-world challenges? Let's take a look at some incredible examples built from nothing more than stone and water.
First up, let's go to the Andes Mountains, a part of the world known for some pretty intense earthquakes. So the challenge for builders there wasn't just to put up a wall, it was to build one that could literally dance with the shaking earth and survive.
And their solution is just brilliant. It perfectly shows this method in action. See, they didn't have seismic engineering, but they had eyes. They saw that rigid walls held together with mortar would just crack and fall apart. So they came up with this amazing technique of carving stones to fit together perfectly with no mortar at all, kind of like a giant 3D jigsaw puzzle. This let the whole wall shift and absorb the energy of an earthquake and then just settle right back into place. Pure genius, born from just watching what works.
All right, let's jump over to ancient Rome. Their challenge was a logistical nightmare. How do you supply a massive city with fresh water from sources that are miles away across all kinds of terrain, using nothing but the force of gravity? The Romans became absolute masters of the gentle, consistent slope. They didn't have formulas for water flow rates. Instead, they built, they tested, and they corrected. If they built a section of an aqueduct and the water just pooled up and stopped, well, that meant the slope was wrong. So they would physically adjust it right there on the spot. It was this constant real-time process of engineering. And, of course, you can't talk about Roman engineering without mentioning their legendary roads. I mean, many of them are still usable today. The challenge here was just pure durability. How do you build a road surface that can handle centuries of weather, foot traffic, and heavy carts?
And once again, the solution came from simple observation. They noticed that a plain dirt path or a single layer of stone would just wash away or break apart. But by building in layers, a deep foundation of big stones, then smaller gravel, and finally a paved surface, they created a system that was incredibly strong. The layers spread out the weight, and just as important, they let water drain away, which stopped the road from eroding from underneath.
And think about this for a second. Massive projects like cathedrals or aqueducts often took way longer than a single lifetime to build. This meant the methods they used had to be simple, reliable, and really easy to pass on. The person who started the project knew that their kids or even their grandkids would be the ones finishing it, so the techniques had to be repeatable without any complex theory.
So this all brings us to a really clear comparison. And we're not saying one way is better than the other, not at all. They are just two fundamentally different and equally valid paths to solving huge engineering problems.
Just look at this breakdown. The ancient approach is all about hands-on learning, testing things in the real world until they break and then fixing them. The modern approach is all about theoretical learning, calculating everything in advance and testing it on a computer. One is learning from doing, the other is learning before doing. So what's the big takeaway from all this? What does this ancient way of thinking really mean for us today?
I think this quote just gets right to the heart of it. It's such a powerful reminder that human ingenuity isn't something that's just confined to textbooks and equations. There is a deep, powerful intelligence that comes from observation, from adaptation, and from good old-fashioned experience.
Ultimately, the materials and the forces of nature, those were their teachers. They didn't try to force some abstract idea onto the world. Instead, they listened to what the world was telling them through trial and error. Their laboratory was the construction site itself.
And that's the question I really want to leave you with. In our world of big data, AI, simulation, and prediction, where we try to calculate every possible outcome before we even start, is there still a place for this ancient wisdom? What can we gain by maybe stepping back from the models and the screens and just watching, building, testing, and adapting? It's definitely something to think about.